Micromeasurements WK series strain gauges have been a staple of stress analysis measurements in harsh test environments for nearly 50 years. The increased fatigue life, very wide operating temperature range from deep cryogenic up to 700 degrees F, high quality and stable carbon foil of WK series gauges make them ideal for a variety of strain measurement applications. A critical specification of any installed strain gauge is achieving a very high resistance to ground. Resistance to ground is a measurement of electrical resistance taken from strain gauge lead wires or solder tabs to the metal or other electrically conductive material to which the strain gauge is bonded. Resistance to ground is also affected by temperature, decreasing as temperature increases. At room temperature, a properly installed strain gauge should have a minimum resistance to ground measurement of 10,000 megaohms. The consequences of low resistance to ground are that a user can expect to see a decrease in stability of the output of the strain gauge and possibly an increase in electrical noise. The conditions that influence resistance to ground are cleanliness of the strain gauge installation, proper design of the strain gauge, and the materials of which the strain gauge is constructed. It is imperative that an installed strain gauge be cleaned with M-line rosin solvent at least 3 times after soldering is completed and before a protective coating is applied. Materials such as flux used for soldering are both corrosive and electrically conductive and will result in a low resistance to ground measurement, even if trace amounts are left on the surface. The backing of a strain gauge, also called the matrix, is the material that provides a bonding surface for the strain gauge, transfers strain from the surface of the test article to the foil sensing grid of the strain gauge, and provides electrical insulation between the foil sensing grid and the surface of the test article. The dielectric properties of the matrix and the thickness of the matrix must be sufficient to achieve a high resistance to ground. WK series strain gauges and all micromeasurement strain gauges will easily achieve high resistance to ground. The chart shows data comparing resistance to ground measurements of micromeasurements WK series strain gauges to a competitor's strain gauge that is intended for applications similar to the WK series. The chart shows greater than 10,000 megaohms resistance to ground for the WK series strain gauge at almost 275 degrees F, whereas the competitor's gauge reaches the same 10,000 megaohm resistance to ground at 175 degrees F, 100 degrees lower than the WK series gauge. The WK series maintains higher resistance to ground throughout the measurement range to 500 degrees F.
Thank you, Becky. Becky, can you describe for us the test setup that was used here in the instrument?
Sure, we have 2 gauges, a WK series strain gauge and a competitor strain gauge here and here. We have bonded them to an aluminum beam, wired them up. At the other end, we have connected our get box to the wires that come off the gauge, and we also have a connection to the test article itself. On the get box, we can then run, we can then check resistance of the gauge. It is a 1,000 ohm gauge, and also the resistance to ground. And we can see that this is above 20,000, almost to infinity in mega ohms.
So as the temperature cools back down to room temperature, the resistance to ground is expected to increase.
Right.
And what we're measuring here is the resistance from the lead wire system through the backing, the adhesive, to the aluminum test article.
Yes.
Okay, thank you, Becky.
Sure, no problem.